I'm Rick Henfling, the lead flight director for the Truss Jumpers EVA. That's U.S. spacewalk number 54. Before we get out and conduct our spacewalk on Monday, we have a few robotic preparation activities that Kenny had mentioned. In summary, we have the removal and replacement of that battery charge-discharge unit. And then we also have an activity to remove the failed lithium-ion battery from the integrated electronics assembly. We're going to take it over to the pallet, which was the component that brought up all the batteries on the HTV-7 mission. Once those activities are complete, we will be in a good configuration to have the spacewalkers take an adapter plate that was originally intended for use with the failed lithium-ion battery, and we're going to move it over and stack it on top of another adapter plate, which is currently in use. And the engineers who developed these adapter plates did a great job in providing a design that allows these plates to stack on top of one another for just this type of situation. And this is a task that we didn't originally plan to do on this spacewalk, but as the third EVA in a series of 3, we understood that it was certainly a possibility that we would need to react to some of the issues that were encountered in real time. And so the team has done a tremendous job to be flexible in the planning of this spacewalk, and we'll be ready to go on Monday.
I'm John Malarski, the lead spacewalk officer for this EVA. As Rick mentioned and Kenny mentioned, we'll be adding an adapter plate relocate. So the batteries themselves are robotically compatible, but the adapter plates were designed only to interface with EVA crew members. So this is designed, a battery can actually interface right on top of this for storage locations. So the robotics folks will take those batteries off, and we will have the crew actually, they have a hex driver that inserts down into the socket here and actually unscrews this adapter plate, and they will pick it up and relocate and stack it with another adapter plate. They'll also have to restore this cable to its original launch configuration. It was originally linked to the neighboring lithium-ion battery, and then it will go to the stowage configuration. Once the crew has stacked the adapter plate, they'll have cleared the way for the robotics folks to install that nickel-hydrogen battery back in place. And then we will pick up with our normally scheduled activities, which we've got a video and animation to show the rest of the activities that are scheduled for this EVA.
US EVA 54 will be conducted by Anne McClain, EV1, in the red stripes, and David Saint-Jacques, EV2. EV1 will lead out of the airlock to the nadir side of the US lab and temp stow the bag. EV2 will be going over the top of the lab. They will meet up at the same work site, but they'll take different paths to deconflict their safety tethers. After going over the top of the lab, EV2 will temp stow the bag on the zenith side of the US laboratory. From here, both will converge on the port side, forward end of the US lab, where they've got a MMOD or micrometeoroid debris shield that they'll release. The crew will work to release that shield and the underlying insulation, then connect the cables underneath. They'll set up their bag with that cable and work to clear the site. They'll remove an electrical connector which will allow them to access that shield, as well as removing a translation aid, known as a gap spanner. Once that's complete, they can access that shield and get underneath to connect an Ethernet cable that will be utilized to route to various parts of the truss for future wireless Ethernet connections. This will spread wireless Ethernet connectivity to payloads on the outside of the International Space Station. EV1 will disconnect the cable, then take the new cable from EV2 and hook it up under the shield. Then they'll replace all the hardware that they previously removed. From there, EV1 will transition to the Node 1 nadir worksite and remove another MMOD shield and route cables for a power upgrade of the space station. These jumpers will be utilized in conjunction with the other ones that EV2 will be routing. This will allow the station to react to external power failures by reconnecting IVA jumpers inside the space station as opposed to having to spend an EVA to reconfigure the power system. Now, EV2 will work from the zenith side of Node 1, directly above EV1. EV2 has a longer set of jumpers that will run from the forward side of Node 1 routing into the S0 Truss through the MLI, where he will temp stow those for EV1 to pick up later. EV2 will wire tie them along handrails to keep them out of the way of any future EVAs. Once finished routing that cable, EV2 will come down and help EV1 secure the micrometeoroid orbital debris shield over the Node 1 nadir worksite. From there, the crew will transition back to the airlock to pick up bags for the next task. EV1 will be heading up to the S0 Truss to pick the cable that EV2 had previously left. This is the one just installed through the MLI on the aft side of the truss. EV1 will enter the bay and continue routing it inside of the truss, separating the blue and red cables. The blue cable will transition to the next bay over to the right, while the red cable will be temp stowed on a handrail for installation at a future time. Once those cables are connected, EV1 will exit the truss bay, enter the adjoining bay, and complete the routing of the blue cable. With the connection of the blue cable, that completes one leg of that redundant power path that will enable the Space Station Canadarm2 to utilize redundant power supplies, if needed, in the event of a power failure. At the same time, EV1 is connecting those cables. EV2 will have picked up what is known as the Bartolomeo training slip-off protection and head to the front side of the European Space Agency's Columbus module. These are plugs that are going on into the end of the trunnions. These are the trunnions that were used to hold the module in the Space Shuttle payload bay for its ascent. These plugs will widen the end of the trunnions to help in the installation of the Bartolomeo platform that will be launched by ESA at a later date. EV2 has installed one and is moving to the outward worksite to install the second slip-off protection.